So example 4.1.1, experimental probabilities. So you can use the following site for flipping a virtual coin. Okay, so here is the web address that you can go to either on your computer, or it works great on a phone too. We've done this in class on the phones as well at different times. So part A says to compute the probability of flipping a head based on the experimental results. Okay. Different than if they just said, assume you have a fair coin, and then the probability of a head would be 1 chance out of 2, because 1 side out of 2 has a head. But based on the experimental results, we're going to look at the number of tosses here was 10, and in those, heads were flipped 3 times. So based on the experimental results here, we would say that the probability of flipping heads is approximately 3/10. Or if we use the notation for event where we just use a single cap letter, maybe we use H, is about 3/10. Or if we wrote that as a decimal, 0.3. Part B says to compute the probability of flipping a head based on these next experimental results. So now they flipped the coin 100 times, and they saw heads 53 of those. So based on these experimental results, we would say the probability of flipping heads is approximately 53 out of 100. So as a decimal, 0.53. And in part C, we're asked again to compute the probability of flipping a head based on the experimental results. And now we can see that the number of tosses is 1,000, and out of those we saw heads 505 times. So based on these results, we would say the probability of flipping heads is about 505 out of 1,000, which as a decimal, we would say the probability of flipping a head is approximately 0.505. Okay, so part D tells us the coin being flipped is actually a fair coin. So a fair coin means the probability of a head is actually 0.5. Okay, so this is the true probability that these experimental probabilities are trying to approximate. So what do the above 3 parts demonstrate? So if we go back up to part A, the actual probability is 0.5. Here our approximation was 0.3, so a little bit off. Okay, in the next case, we flipped it 100 times, and again, if the actual probability, true probability, is 0.5, our approximated probability here of 0.53 is not that far off. And in part C, again keeping in mind the actual true probability is 0.5, our approximated probability came out to be 0.505, so really, really close to 0.5. Okay, so what do the above 3 parts demonstrate? Okay, they demonstrate the law of large numbers. As n increased, as we repeated the experiment more and more times, these approximated probabilities, experimental probabilities, tend to get closer and closer to the actual true probability. So if the coin is actually fair, then the probability of flipping heads is 0.5. And we can see above, as n increases, the experimental probabilities got closer to the true probability. Okay, so this demonstrates the law of large numbers. So again, in repeating these experiments where they actually knew the true probabilities, and they could see that the more times they do those experiments, that those experimental probabilities tend to get closer and closer to the actual ones, is what allowed them through probability theory to kind of extend this concept to things that we don't know the true probability for, that if we know if we just take a large enough sample or survey enough people or objects or whatever that may be, that those experimental probabilities that are approximations, we can have faith that they're pretty close to the true probabilities as long as we take a large enough sample size.